In this video, we explain how to prepare a jar for deployment as a Fuse application bundle or FAB. To take a specific example, we take an existing Maven project that is configured as an OSGi bundle and show you how to convert it to a FAB. The example we are going to consider is the CXF proxy example from the standard Apache Camel distribution. The CXF proxy example interposes a camel route in front of a CXF web service, so that the camel route acts as a proxy for the web service. From the point of view of deployment, the most interesting thing about this example is that it uses some standard components provided by the ESB container. For example, the camel CXF component, which integrates a web service endpoint with the camel route. The camel HTTP component, which enables the camel route to forward requests to the real web service. And the CXF bundle component, which provides the complete runtime code for Apache CXF. As we will see, when using a FAB, it is important to be aware of the components that are already provided by the ESB container, so that you can avoid redeploying these components in the FAB's own class space. Now, let's see how to refactor the CXF proxy example as a FAB. For our starting point, we have already renamed the project to Camel CXF proxy FAB and modified the POM file to get rid of its dependency on a parent POM. Let's open the POM file and see what modifications we have to make. The first step is to edit the packaging type and change it to a jar. A FAB must always have the jar packaging type. Next, we need to look at each of the Maven dependencies and decide what scope they should have. As a rule of thumb, any dependencies that are provided by the ESB container should be marked with the provided scope. This is important because otherwise the FAB runtime would automatically try to download and install those dependencies into its own class space. Now, when we come to the CXF dependencies, we replace all of the existing dependencies by a single CXF bundle dependency. We can do this because the CXF bundle is a super bundle that contains all of the bundles for the CXF runtime. And this approach is economical because the CXF bundle comes pre-installed in the ESB container. But remember also to mark these dependencies as provided. Next, we come to the logging dependencies. It's not immediately obvious from the POM, but if you check the Java source code, you can see that the logging dependencies are used only in the unit tests. These dependencies must therefore be marked with the test scope to make it clear they are not needed at deployment time. It turns out that it's important to mark all test dependencies in a FAB, otherwise the FAB runtime would try to install these dependencies in the ESB container at deployment time. If we have a look at the Maven plugins, we see that this example requires the Maven CXF CodeGen plugin, which generates Java stub code from the WSDL contract. The Maven bundle plugin configuration has already been removed from the POM because it is not used by the FAB. The next step is to convert the Spring XML file into a Blueprint XML file. We strongly recommend that you use the Blueprint framework with FABs. Blueprint has a built-in mechanism that dynamically locates and imports dependencies introduced by XML namespaces. For trouble-free deployment of jar files, the Blueprint framework naturally complements the FAB deployment model. Let's take a look at the Camel Spring XML file which we are about to replace, and the Camel Blueprint XML file which has already been partially created. We have already created a stub for the Blueprint file, which contains all of the namespaces and schema locations that we need for this example. Notice how the namespaces used in Blueprint XML are slightly different from the namespaces used in Spring XML. For example, the Camel Blueprint namespace URI ends with the word Blueprint instead of Spring. Now, let's have a look at the Spring XML file which we want to convert to Blueprint. In the original CXF proxy example, the CXF web service is created by the real web service bean. which uses the pure JSWIS API to instantiate the web service endpoint. This is not the ideal way to instantiate a CXF web service endpoint in Blueprint, however. It is better to use the JSWIS :endpoint element instead. So when we translate this piece of XML code to Blueprint, we use the JSWIS :endpoint element. The implementer attribute specifies the name of the Java class that implements the web service. And the address attribute specifies the location of the web service endpoint. For the rest of the configuration, we can, at a first approximation, cut and paste the remaining contents of the Spring XML file. There are just two corrections to make in Blueprint. The prefix used for the camel-cxf endpoint in the Blueprint file is camel-cxf, and the camel namespace URI must end with the word Blueprint. And that completes the conversion from Spring XML to Blueprint XML. We can now delete the Spring XML file. Now, open a command line prompt and build a modified example using Maven, skipping the unit test. We start up a local instance of the Fuse ESB container. To install the FAB, use the regular OSGi install command, where the URI is prefixed by FAB:. The FAB: prefix ensures that the jar is deployed as a Fuse application bundle. Now see what happens when we start the FAB bundle. Use list to check the status of the FAB bundle. We can see that the bundle is active and the Blueprint container has been successfully created. We can also list the CXF web service endpoints to make sure they are active. Finally, we can demonstrate one of the special capabilities of a FAB. If a FAB requires a certain Carafe feature, it has the ability to install that Carafe feature automatically when it starts up. First, uninstall the FAB bundle, then uninstall the Camel HTTP feature, and then uninstall the Camel CXF feature. Now, reinstall the FAB and start it up. By listing the bundles, we can see that the FAB bundle has successfully started and both of the Camel CXF and Camel HTTP features have been reinstalled automatically.